Okay. So, fact and dimensions that I have mentioned in yesterday's session, we need to store the table in data warehouse and or data mart in the form of a fact table, or it can be a dimension table. Now we need to choose from the source system. From the source system, we are receiving lots of columns, lots of tables. Inside that table, lots of columns should be there. We need to identify which column should be residing in fact table and which column should be residing in the dimension table. So the first thing we need to decide what are dimension and what are facts, and we need to segregate different dimensions and the specific measures column in fact table. Okay, so that is the reason. First, we are checking what are the fact columns. Fact columns, that is numeric, that should be numerical in nature. That there is unnumeric, I mean non-numeric data as well for fact. But generally, fact should be always numeric in nature. So over here you can see in the example the revenue, cost, number. So those are measures or facts. We can tell it fact. And we need to contain this thing in a table that is called fact table. Okay, let me just increase the size. Yes. So in this first table, sales table, you can see there are sales, quantity sold, price, discount. So all those columns, it's resided over here in sales table. So those are all measures or fact. So instead of only having the measures value, the fact table is consisting those different keys as well. It's similar for billing table. Then mention, you can see the mention thing are just like key, something key, stored key, product key. So those are all fact, and the upper portion, the key name things are called foreign key, because those key will be required. The individual key is a primary key for a particular dimension. Suppose we have a date dimension. Over there we have date key, maybe year, month, date, I mean month, day, those are been extracted with different columns, or maybe the quarter end for each of the record. So all those things are coming from date dimension table. There is a store dimension that I showed you yesterday, product dimension. So each of the dimension table, there should be having one primary key. From the date dimension, there should be date key as a primary key. For store dimension, there should be store key as a primary key. For product dimension, there should be product key as a primary key. So for the fact table, we should be having each of the foreign key, which are the primary keys for other dimension. Let me show you in the dimension example, then that should be clear. Okay. Okay. What are the different dimension? Dimensions means just like in a particular project or applications, you must have been some other non-numeric data. Suppose customer, time, okay, employee. So those are all dimension. Just like store dimension. Store dimension is having store key as the primary key and all the store related information as the separate dimension, where all the things have been contained in a dimension table. Similarly, in product table, product key is the primary key, and product ID, product name, product group, brand, department. So all those product related informations, we kept it in product dimension. That is how dimension table works. And I also give you the concept in yesterday's session. Fact tables, the data in fact tables is very huge because it's the main transaction. Okay. Suppose I'm working in I'm in a particular shopping mall that I told yesterday. In the shopping mall, we should be having store ID because there are lots of outlets in different city. So each of the stores should be having a store key, a store name, individual address for each of the outlets. For product related information, what different kind of products our store is selling. Okay, so their IDs are there, the different product name, brand, group, all those things are kept it over here. but the dimensions are not changing daily basis, because maybe the scenario is there, we are not introducing a new product in tomorrow, we are not introducing another product in 1 or 2 days. Okay, so that is why it's almost very static, not exactly static. Maybe a new outlet has been introduced in a particular new year or just like this, then we need to, then one row should be added, one record should be added, but the change is very infrequent in dimension table. Okay, even the data volume is very less, but in fact table the data should be huge, because this is the transactional level data. Whatever daily basis transactions are happening, those are mainly captured in fact table. Because I mean that's like billing, sales, those kind of things daily we are, I mean daily the things are increasing, but the products are same. There is no extra product. New people's, okay, customers, maybe there should be a new customers. Customer dimension can be increased a bit comparing to these things. Maybe new customers came there. Okay, so that is why particular dimension can be having a frequent, but not such frequent like fact table. Okay, for customer information, suppose I'm storing all the customer related information. A customer key should be there, and apart from that, customer name, customer contact number, customer address, those kind of thing, I can check it. Okay, so uh, those are called dimensions. Each of the dimensions you can see a primary key is there, and those primary key will be required when we will be creating data modeling. Let me check where is the data modeling. Okay, I'm just quickly going to data modeling concept, then I'll be coming to this topic again. So as of now, fact and dimension concept is clear, Varti. Hi, Varti.
Yeah. Yes,
Okay,
yes.
okay. So I am just going through this topic quickly, the data modeling. So data modeling is just like this kind of thing. We need to model the data such a way. I mean, we are preparing the data for OLAP analysis, OLAP. We have discussed what is OLAP in last session. So we are going for a good analysis part. Before doing that thing, we need to prepare the data modeling. Okay, so we have the single fact table over here. In this example, we have only one fact table, but in the dimension, there is no such rules, regulation. There should be only single fact table. There can be multiple fact tables, but generally we used to maintain single fact table, because all the measures related stuffs we trying to kept in a single fact table, and there should be multiple dimension tables surrounding it. Okay, over here in this example, you can see in the fact table till this promo key, all those things are I mean foreign key over here, and each of the foreign key is the primary key of the dimension table. Just like time key is a primary key of time dimension. Store key, we are keeping it store dimension. Clark key, we are keeping it Clark dimension. Promo key, we are keeping it promo dimension. So in the second day of the session, we talked about how we can normalize the table. So that is the way now you are understanding. We are normalizing the data warehouse over here. We are normalizing the thing. We are segregated the data within fact and dimensions over here. Okay. So those are different dimensions surrounding the single fact table, and each of the dimensions are normalized in nature. Okay. So this is the concept, and data modeling. This is how the data modeling works, because we can have the concept. Suppose I quickly required a particular relation between this data with maybe with a store name or store address. Then I can quickly check the data modeling, and I can quickly join the store dimension and the fact table based on store key and pull all the store related information. Okay, so data modeling is one of the important thing that should be handy if when we are creating any data warehouse or data mart. Okay, we should be having individual tables. Suppose in data warehouse, in a database, we are creating one fact table and multiple dimension tables. So when required for OLAP analysis, we can quickly join all those things. Okay. Suppose I'll be joining with these two, the time key, these two with the product key. So all the things should be, all the columns should be present in OLAP analysis. That is why when doing OLAP analysis, it's told that OLAP analysis, the final data set, it's not normalized. But before that, the data is normalized in nature. When we'll be doing OLAP analysis, means when the table is ready for reporting purpose, if any one of you are working in reporting part, we are putting some query over there. So when we are putting the query, we need to merge all the tables in a single data set. That means we are joining with the each of the primary key and foreign key, time key with these two table. So you are pulling all the columns together. Only one single table or single view should be there where all the columns should be present, because then only our reporting will be successful. While doing the reporting, we are not keeping segregated between fact and dimension tables. We just need to check the data modeling and join between them and keeping all of them in a single table. This single table storage system is called OLAP analysis. This is ready for the analysis part. Okay. Now that data should be fed maybe in Tableau dashboard. In Tableau dashboard, whatever columns is required, they will be pulling and they'll be creating their own charts and graphs. Similar things for Click, Power BI, any other tools. Okay. And one more thing, when we are joining this thing, we must have to maintain the cardinality. Cardinality means the relations of fact table and the dimension table should be one-to-one relationship or many-to-one, one-to-many or many-to-many. This kind of cardinality we need to maintain. Uh, Let me show you with a good example. Okay, if I can quickly check it over here. I didn't put cardinality examples in data modeling. So please check this thing. And if there is any stuck point, please ask me the questions. Okay, just put cardinality in data modeling. Just like this example. Okay, this is not a good one. Just like doctor and patient. So this is the cardinality. I mean, you can see it's many to one relationship. I mean, this is the, over here, I'm representing this thing in a single line, but in a good data modeling, you can see something should be started with three. That means many. This means many to one. Uh, Lots of patients should be tagged with single doctor ID. It should be the scenario. And over here, a single stripe and a circular thing is there, which represented this many can be optional, but the single stripe is mandatory. This is also not there for many of the data modeling. They are not keeping this circular part and this part. So when we are doing the data modeling, then we should be have maintain this kind of thing, many to one. Okay. Uh, Generally, in general cases, most of the data modeling nowadays we are doing in this manner. We are not keeping many to one, but the main thing is the fact table is the base table. So we are keeping all the records from fact table and doing left join with the time dimensions or the other dimensions. Okay, the base table we are picking, which is called fact table, and maybe we can do inner join or maybe we can do left outer join. That is totally dependent on the cardinality of this. If the cardinality is one-to-one relationship, it should be having inner join between the keys. If the thing is, okay, I have a question. What is data modeling versus cardinality data modeling? Okay, there is no such difference. Data modeling, the best practice is we should have to maintain the cardinality as well. Not only single line over here, just we can maintain in this way. So the things will be totally completed. This will be helping us whether creating the OLAP analysis will be joining this thing. It's a left join or it should be a inner join. If this is only single, one-to-one relationship, then it should be inner join. Okay. If there is many-to-one relationship, then it should be left join. That's the concept. Because we need to keep all the transaction. The thing is just like this. Maybe we have lots of products. Okay. But a particular product was not been bought or sold in the fact. Fact will be just keeping the data which is having the transaction. Maybe in my outlet, I have such products which were never been sold. Or that's why in fact we did not get this kind of transaction. Okay. So now the question is whether in the final OLAP analysis, should I keep those kind of product information with null value of sold part, or should we should not do this thing. As of now, we should not do these things. I'll be keeping only the records in OLAP analysis which is having a valid transaction. So that is why all the product cannot be captured over here. So in the final OLAP analysis, I will not be able to understand whether a product is existed in the factory or not. Okay, that is why the relationships should be coming. Okay, some questions is there. Are we building database schemas using these techniques? No, yeah, database schemas means when we are creating the data warehouse, we need to keep the fact and dimension separately. Suppose in the same data warehouse, I just showed you. Okay, let me open a database just like MySQL. I'll be coming the questions one by one. Maybe when we'll be doing the hands-on part, that should be much more easier. Or maybe lots of confusion is there. So suppose I created a data warehouse. Suppose the data warehouse name is this world schema. Okay. So when we are just storing those tables, we should be having all those tables. There are 1, 2, 3, 4, 5, 6, 7, and 8. 8 tables I'll be creating into my database schemas over here. Got it? Now, when I'll be pulling those records for reporting purpose, okay, I have all the segregated tables. But when doing the reporting, when I'll be creating charts and graphs, before creating just before that instance, when we'll be creating the charts and graphs, I need to combine all the records together, combine all the columns together. Then the join, we should be joining between them to get a relationship between, because in the particular charts and graphs, I'll not be going to show the stored key versus union store, union sold, unit sold. Rather than I have to using particular dimension instead of that, which particular outlet is having maximum sales quantity. So I need to pull the other dimensions with the fact relationships. So that time we need to join all the things together. Okay. Did you get it? Yes. So we need to join before creating the charts and graphs. That is the question. I mean, things. I mean, in the last exercise 2, I have provided that if you just go through that exercises, the second exercise that I put on last Monday, I believe. Yeah, there I have chosen each of the columns from each of the table. At first I created 3 or 4 tables in Excel sheet, and I told you to create a final data set picking up important column from each of the data set. So the same thing over here. When we will be going for reporting purpose or visualization purpose, we need to have the relationship between individual dimensions and facts. Because in the charts and graphs, we will not be going to show the key. Those are the primary keys. Primary keys will not be shown. Those can be a surrogate key, product key. A particular product key, I'm just giving an alphanumeric code. Suppose 1, 2, 3, ABC. Okay. I'm not going to draw a graph between a product key versus their unit sold. Rather, I can put from the product related information, where is the product key? Yes. So I can create a brand versus unit sold. This kind of charts will be much more meaningful. That is why join is required for all individual fact and dimensions, and to get all the columns in a single table. And that should be required just before the reporting tool. I mean, report purpose. The concept is clear now. Who asked the question? Actually, let me check. Yeah, Sadhvi, you just asked. I think it's clear. If not, please tell me once more time.
Can you explain one more time?
Which one, Bharti?
This fact and the one which you are explaining.
Okay, the data modeling part. This is called data modeling.
Data modeling.
Yeah, the data modeling is useful actually when we'll be creating the fact and dimensions. Before that, the data modeling is required. So we need to, the main concept of data modeling is all the dimensions should be normalized in nature. What is normalization that we have discussed in the second day? There should not be any partial dependency of individual columns with the particular main primary key. Okay, if there is any partial dependency, segregate these things out and create a new dimension. That is why we can normalize a particular table. It's been mentioned in second class. So if there is any issue, please go through this thing once more time. The concept should be clear. Now, that is how we can normalize the table. Based on the normalization, we need to determine, or the architect need to determine, what are the different kind of dimensions should be there to establish a particular data modeling. They need to think, yes, this is a important dimensions. This can be important dimensions. This can be important dimensions. Okay. So all the dimensions, they need to chalk it out, and a fact table should be there. For individual dimensions, they will be storing individual foreign key over here, and the rest of the thing should be separate. I mean, different transaction level data in measures. Okay, let me give some example. Suppose I'm working in a banking sector. Okay. So for banking sector, what can be different dimensions? Dimension tables, rather we can say. Suppose, yes, customer dimension, there all the customer code should be there. What are the things? Employee dimension, all the bankers, employees should be there. Branch related information, what are the different branch code, their addresses and all. What are the different things? Time dimension should be a common dimension. It should be there. Okay, and in the fact table, all the credit, debit, all the transactional related information should be there. Customer key, employee key, credit, debit, branch code. branch code should be the primary key. So those are the different things, so that we can set up relationship which customer debited how much money from which branch. Okay, so this is the thing. Now I'll be coming to the point how fact table is been designed. Okay, how much lower level of transaction we should be thinking of. So data modeling is just like this. We need to prepare this thing earlier, because we need to clear the concept what are the different kind of dimensions and fact to establish the entire logic. Okay, I'll be giving some example. Let's just quickly check these things. If the concept is still not clear, I'll be showing this thing again tomorrow. And I'm trying to prepare a good exercise in front of you. It's not, I mean, just like functional knowledge. There are lots of softwares which can help us with data modeling only. Okay. Now I'm just going how the fact and dimension tables are created. Especially fact. I'll be focusing on fact now. Okay. While doing the fact table creation, we need to think about these two terminology. One is called grain, another one is called granularity. Okay. First, I'm going to grain. Grain will be helping us for an individual record or individual row, what it signifies. Okay, I'm going to an example, then that should be easier. So this is a fact table. In the fact table over here, you can see only two fact data is there, quantity and amount. And the other things are the foreign key, sales ID, bill number, date, item code, store ID. Okay, those are primary key and foreign key. Bill number is not a foreign key. Bill number and sale ID, we can say these are primary key of this table. Combination of this thing are just like this. Okay, or maybe bill is a separate dimension, so you can also store it. You can see bill is repeated over here. B2304 2014. Okay, let's see what is grain first. So what is the grain of this fact table? We need to check what a particular individual row, what the things they are significant, what are the significance of the individual row, or in a single line how we can define this thing. I mentioned this thing in the subject. So sales transaction for each store, per each item, per each date in a bill. So just like we are putting each for each of the foreign key. That's it. So the transaction is there, and whatever different column or rather foreign key we are introducing over here, that we have just put per this, per item, per store. Okay, per item, per store. This is called grain. I'm going another example, just like this one. Marks of a student got in a subject in a particular exam. Okay, so this is the fact table. In the fact table, you can see marks is there. This is the main fact. What are the other things? Subject. Maybe over here it should be subject code actually, if this is a fact table. So subject code should be here, and in a subject dimension, there should be subject code versus subject dimension. But over here, fact table is not exactly the normalized one, but you can get the idea. Okay, so what are the things? Year, batch, exam name, student name, subject, marks. So that is how you can tell it. Marks of a student for a subject in a particular exam. Okay, we can also put in a particular batch in a year as well. There will be no issue. We are just taking into consideration for only 1 year. If this is the scenario, that is why maybe this is not mentioned. Now I'm giving an example over here. Let me repeat one more topic, then I'll be going to example. This is called grain. Okay. Just I mentioned what are the different dimensions I'm going to introduce in a particular fact table. or rather the foreign keys of the dimensions in a fact table, just the same facts and individual dimensions. We need to put it over here. And what is granularity? Granularity means how much granular level or how much transaction level we are capturing the thing in a particular fact table. So based on the, decision of the customers, maybe from the architect, how much granular level we need to carry the data means if it's totally the transaction level, how the transaction levels are appearing from the source side, if we want to keep in the same way, then that is called the atomic level data, and that data cannot be break more than that. And if we aggregate the things, okay, if we are aggregating the things, we are summing up the things based on some dimensions, because maybe for analysis purpose this is not required, this level granularity is not required, so that is called low granular data. So high granular means higher level of transaction, and sorry, the atomic level of transaction we are showing over here. Okay, and low granularity means the data is getting summarized or aggregated. Okay, now I'm going to give an example how granularity and grain are interrelated. You can just quickly check this exercise, then I think the concept should be totally clear. Please repeat grain and granularity, sir. Yes, I'm just repeating with an example. Okay, then the thing should be clear. Okay, this is a new Excel. Let me introduce the same exercise, same example. I'm creating a particular students. Okay, student year I'm not putting. Suppose a single year. Yeah, let me put here. Okay, fine, no issue. Then what are the things? Exam name. Should you put exam name? Then student name, fine. Subject. I'm keeping only this 5 column in a particular year. Suppose I'm taking 2022, 2022, 2022. Let me keeping in this year only as of now. I'm keeping this many records. Okay. Exam name. Suppose we have 2 semester in a particular year. First, same. Student name maybe Krishna. Putting this thing. Subject maybe or subject. Okay. Let's put maths. Marks. $60. Okay. Same thing should be there. Second same. Same thing should be there for this thing. Let me put physics. Pallavi is having any other subject, geology, suppose getting 80. Botany Okay, suppose this is a mark sheet I collected asking some information. So over here, what is the grain? I can tell marks of a subject or marks of a student for individual subject for individual exam in a particular year. So the mark should be there, and for all the individual dimension I need to mention over here. Now what is granularity over here? So over here we can capture in this much granular level. Suppose my requirement is I can summarize the exam name. I should not go up to granular level for each of the exam. Suppose I got the instruction in my fact table, I do not have to maintain the exam name column. So I'm omitting the grain. I'm updating the grain. I'm eliminating the exam name over here. Okay. If this is the scenario, let me hide it. I'm hiding it. Okay. Now my grain has been affected because I have omitted one exam name. My grade affected. Now I can tell marks for individual student for a particular subject for year. My grade should be also affected. Over here, there should not be two different rows now. The things are aggregated, sum up, and only one row should be there. So we are going for less granularity. So the thing is, when we are decreasing the grains, the decreasing the column names, then the thing should be summed up. Just like now we should not be having this row anymore. I'm hiding it. And rather 60 plus 70, that should be 130. So it's lower, it's not granular level up to semester. It's granular based on individual student and each particular subject, what is the marks they are receiving. Now I want to delete subject as well. Okay, means I don't want to check subject in my fact table. I just want marks for a student in a particular year. I just want to maintain only this thing. Okay. So I affected the grain over here. Grain means I just deleted one of the dimension. If this is the scenario, it can also affect the granular, because over here for Krishna, two different subject I was mentioned over here, but now subject is removed. So the things will be sum up once more time. I need to hide it. Any one of the row I can hide, and I can just aggregate it. We received how to sum up. We know how to do this in SQL. The same thing is here. So now this is the data, but it's not up to the granular level. Okay. The concept is clear now. How it's affecting, how the grain and granularity is changing. Granular means it's not atomic level of transaction. Okay. Let's increase the granularity once more time. I'm just doing Control Z. Okay. So this is the earlier data set. If I want to make it more granular, I need to update the grain as well. How much, if how I can make it more granular? Let me think. First thing. Okay. I'm updating one more. I'm introducing one more column over here. Just like written or practical. Yes. Whether it's a written or practical. Okay, I can introduce this thing. Okay, for maths, actually for maths, no such practical should be there, but I'm still introducing. So for this thing, So for each of the line items will be segregated. So we are going ahead with more granularity. Okay. What should be the thing? Let me show you. Insert a row. Okay, I'm inserting the same thing. Thing is, the written marks I'm putting W. For practical, it should be P. So maybe for written it should be 60. Total full marks is 60. For practical, it should be 40. So I'm just segregating this thing. He's receiving 40 marks in written and 20 marks in practical. So we are going at with more granular level now. We introduce one more dimension over here. Okay. So the grain has been updated. This should be affected for all the rows. Each of the rows will be segregated with two new line items. Because we have updated the grain, that is why granularity is also affecting here. I hope now concept is clear. We are going ahead with more granular level. Generally in fact table, we try to maintain what the transaction level we are capturing the data, the same way we are trying to capture from the source side. Because whenever it's required, we can sum up in our reporting level. But when we want to bring back the things from atomic level, if the fact table is not designed such manner, we cannot get it back. Okay, someday user wants to check the report at the atomic level, the lowermost transaction level. If our fact table is not designed such a way, if we are doing the aggregation in the fact table itself while populating data in the fact table itself, then it will be very hard to get the atomic level data in the reporting layer. So that is why we'll try to capture the data or design the fact table such a way it should capture the lowermost granularity, as well as it should maintain the same grain. All the dimensions should be involved over here. Whatever dimensions it's required at the KPI side, means at the reporting side, all the dimension we need to think, because it's a top down approach actually. User needs to think what should be the charts and graphs first. Okay. Based on these charts and graphs, what are the different dimension is required? I mean, which relationship is required? A particular customer's transaction we need to check. Their credit and debit related informations we need to check. For a store, okay, I'm checking a particular customer city and address, and whether they are visiting their local outlet or they are visiting somewhere else. If they are visiting somewhere else, leaving their local outlet means there is some issue with the local outlets. Maybe the behavior of the employee is not good. Maybe the particular stock of the product is not good in the same outlet. So that thing we need to know. Then we can get the hidden strategy. I mean, what is the hidden pattern behind it? I need to have an inspection. What is the issue of this particular thing? Okay. So this is the thing. Checking upon the data, we can get lots of answers, and that thing will be solvable, and the business value should be increased. This is the main motto actually. We're doing the business intelligence at the data engineering part. So till this topic, grain and granularity, if there is any stuck point, I have also covered this data modeling a bit. Any stuck point from anyone? Okay, I believe no. I'll be trying to prepare another exercise or any other thing on top of data modeling or grain and granularity to showcase the thing once more time. If I cannot do these things, then definitely we can try to cover this thing in Python, or another exercise on top of a data warehouse. We'll be creating the thing maybe in this database or any other thing and try to join it back. But in the second exercise, I have given this kind of exercise actually. If you can quickly check the exercise, I have given one fact table and two dimension tables there. Okay. And at the output, I want a particular, merging of the data based on particular columns. So kind of a data modeling you need to think about first, and you need to join based on that. I think Ramya, you shared me the code. There is a
Yeah.
just syntactical issue was there of join. Please check.
Mhm.
I think you can get it.
Okay.
You're putting join there, but you are not putting on. You are directly doing where. Just like join syntax is mistakes over. I mean, there's a mistake of join syntax. Please check it.
Sure, I'll check it out.
Okay.
So one more thing. Uh, I'll just tell you what I understood about the granularity. Please correct me if I'm wrong, okay?
Okay.
So if we add more dimensions, that means more columns, the granularity will be increased, right?
Correct.
So if we
Yes.
consider more columns into calculating the one record, then the granularity is high. And if we consider less number of dimensions, the granularity is low.
Correct. Correct. You're absolutely correct.
So
Now the thing.
what
Yeah.
the grain is that each record is called a grain or
Yeah. Each record, what it signifies. For this kind
okay.
of thing, we can say marks of a particular student
Mm-hmm.
in a particular subject in a
Okay,
particular paper. Over here I can signify this thing. Paper means paper 1, paper 2, uh,
right.
in a particular exam I told in a year. Okay,
Mm-hmm. So
this should
each
be
entry is called a grain.
grain. Correct. Now the thing
Okay.
is, in the transaction level, maybe in a shopping outlet, we need to check a particular customer, what are the dimensions are involved over there in the shopping outlet, we can determine over there, and we can keep it in this way. Suppose that in the transaction level, the particular dimensions is not introduced at that time. Okay, suppose this one, we do not have the information of paper, but our users is telling, please include this much granular, but we do not have the information at the source side. So that is why it's not possible if we are not receiving this kind of dimension at the source side. We can supposed to do, I mean, a particular, I mean, doing a wild guess, we can segregate the things. There'll be no issue. But that particular dimension must have to introduce from the source system itself. Otherwise, we cannot able to make it. So what is the source level transaction? We try to follow the same granular way we need to maintain in our fact table. Unless there is any other requirement of aggregation at the fact table. Okay. Okay. Those are very, very important concept. Not very much technical, but the concept should be clear for everyone. Okay, now I'll be going to something about dimension. Whatever I had discussed on top of grain and granularity, that is mainly focused on fact table. Okay. Now about dimension, there is three important concept. As I mentioned, dimensions are very slowly changing because maybe daily basis the dimension table should not be affected. A new dimension rows cannot be introduced in the very next day. Okay. Suppose I have employee dimension. I mean, the same employee number should be there in my very next day as well. Maybe no freshers has joined into my company in the second day of my office. So that is why the employee dimension table will not be updating daily basis. So how to, I mean, what are the different strategy of slow changing dimension? That is why we call the dimensions actually slowly changing dimension. And there are three types of maintaining the data in the slowly changing dimension based on what are the columns we are picking it up. I have a quick example in one of the Excel sheet. Yeah, this one. So SCD type 1, SCD type 2, and SCD type 3. We have this exercise, this example over here. Let's quickly focus on SCD type 1 first. This is the simpler one. I have kept employee dimension. All the employee related data should be kept over here. So the primary key should be employee ID. Okay. And the dimensions are employee name and their designation. I'm just only keeping this thing. Okay. Only employee ID, employee name and their designation. Suppose a new employee has been introduced in the next month first date. Okay. So when that day's data I'm loading from the source system, I receive two information actually, two updated information. First one is you can see the employee ID 1. That employee has completed 1 year for that particular day. And in the source system, I can see the designation of trainee, across trainee of this particular user has been updated to developer. Okay, he is not trainee anymore. He or she is not trainee anymore. His designation has been updated from the source system as developer. Okay, and I can see one more change. A new resource has been joined. So in the same day, I checked there is two change from the source side. So that is why I kept it in the dimension as well. But in the dimension, suppose such a day, I need the information which is the particular, I mean, whether the particular developer has switched from a particular company and directly joined as developer, or he has joined as a fresher. This will not able to help me if we just quickly check the dimension in certain days. This will not solve my question. So to maintain the history of the dimension, we are increasing the features in the dimensions. That is called type 2, SCD type 2. We are keeping some date. That is how we are maintaining the history. Which is the transaction date? Okay, let's just check the. I'm just doing a bordering part. So the same, example I'm giving it over here, just keeping only one date. Okay. So over here, I'm keeping both of the records, ABC trainee, ABC developer as well. And I'm just capturing if a particular update date that has been updated. So the particular thing has been inserted in a new row with, and this field has been updated for particular which date the transition happened. Okay, that means if we have multiple rows for this, we can confirm that this particular employee is not a fresher. Is not a. He is joining from the company as a freshers, and his designations got updated. Now, this kind of decisions we can take if we have just a one column, just like date or transition date. Okay, so this is the storing pattern of the data in dimension in SCD type 2. Just introducing one date column. So if there is any update for an individual or any update or any insert of a new record or an existing record is getting updated, that can be captured by this date column. Okay, so this is the just the change from SCD type 1 to type 2. This is SCD type 3 as well. So if we just going to SCD type 1 to type 2, the dimensions should be having much number of records only. You can see the record count has been increased. We do not have only one single record for this now. We have two different records for this. Only changes in the designation and the transition date. Over here in type 3, we are not increasing the number of rows over here. Rather, we are increasing another columns. Transition date is there, and we are also keeping previous designation. So we are keeping only one row for this scenario, and we are just keeping previous designation and keeping one more column over here with having the previous designation, which is having previous designation is null. That means they switched from other company to this company. Okay. So in SCD type 3, we are introducing not only date, the date is also there, which we have introduced in SCD type 2. And we are also keeping the previous designation. This thing we are doing just to remove or eliminating these two. Two records over here or multiple records over here. Okay, for an individual employee ID. Especially, users as of now in the business, we can see they're following either SCD type 1 or type 2 while designing the dimensions. So we need to follow in the same manner. Sometimes they should be very much simple. Suppose that their dimension is not much important. We do not need all those information. So that is why they just follow only ACD type 1. Okay. So this is based on totally based on requirement. What is the requirement from the source system? How the architect just have their architecture and what are the columns they required? How they want to maintain the data, the source side. So everything will depends on the decision made by them. Okay, so this is how ACD type 1, type 2, type 3 is there. How we are storing the information at the dimension side. Whether we need to keep the history on. This is the main mode. Okay. Okay, we have already covered up the time. Just I'll be repeating some more things. Okay. Okay, as of now, any doubt? Otherwise, I'll be covering the rest of the part in tomorrow's session. I'll be introducing ETL only tomorrow. Any doubts so far? Okay, I hope no. Just try to check this thing, especially data modeling, grain granularity. I think the concept is already clear with this example. Dimensions, just check with the ACD type 1, type 2, type 3 as well at your side. If there is any stuck point, please ask me questions in tomorrow session. Okay. And tomorrow will be I'll be just having some more scenarios from website or just like this. Let me check. I'll be giving this exercise to you so that you can create this kind of data modeling at your side too. Maybe in Excel. Excel with just like this kind of lines and all. Creating in Excel. Okay, there is some more topic on top of data modeling. Let me cover it today. I mean tomorrow only. Tomorrow I'll be covering these stuffs. The ETL concept. What are the separate kind of data modelings are there, and the KPIs. KPI is the main unit of the dashboard part while doing the reporting and all. So those concepts I'll be trying to clarify in tomorrow's session. Okay. So I hope there is no doubt as of now, but still check the things because those are very much conceptual. When we'll be creating a end-to-end design or end-to-end development activity, then those are very much helpful. Okay. Okay. That's all for today's session. Let's connect tomorrow. Thank you, everyone. Bye bye.
Thank you.